The next we will see is about malicious software or malware. This is another latest trend of attacking your system. Now we saw in module 1 that one way that malware, this malicious software, can spread is through emails and also through unauthorized downloads. We had a mega upload case study, if you remember, in the module 1. And what happens is that through these emails and through these unauthorized downloads, the malware actually sticks to these files and emails, and the moment you go and click or open these files or the attachments in the emails, the software gets installed. So and actually it gets installed with the privileges of the user. If you had clicked it, it actually gets your privilege. And after getting installed in your system without your knowledge, what can this do? It can go and change or destroy the data in your system. In that case, it is an active software. Or it can just observe all the transactions that you do and communicate it without your knowledge. In that case, it is a passive attack on your system. And it can also create some random packets and keep pumping into the network, creating trouble for the other computers in your proximity. The other interesting virus that you had seen is that this could keep quiet, and whenever there is some removable storage like your USB pen drive comes without this virus, it can just basically replicate itself into that USB, and that when the USB goes to some other place within the network, it can go and infect that system. And when the USB from that system is come and inserted back into the system, then some data of that system can come here and get transferred. So if you have an office where there is some, you have made a complete distinction, there are systems which use the computers and there are some systems which are not connected to the internet, there are systems which are connected to the internet, then it is a very, very valid request that somebody wants to say read a paper, a research paper, and so they go and download it from the internet, put it in a USB drive and come to the other office, insert it and start reading. Along with that USB, in that USB drive, it may not be just the paper that is transferred, but it can also be a malware. So the malware enters from office A, which is connected to the office room A, which is connected to the internet, to room B, which is not connected to the internet. Now here the malware can collect some information, and someday this USB goes back to room A, then it can transfer it back to the internet. So or it can come here and it can the malware can move from room A to room B and it can start creating issues at room B. So this is how your malware can even reach out of net reachable resources. Even the network internet cannot reach there, but your malware can still reach. And this is basically possible because we have removable media. That is why in many organizations USBs are disabled. Now these are the 10 top malware threats. So statistical data we got from sophos.com, in which I did mention the Sober the Sober actually was the software which gave a wrong email and intimidated people by using some big words, and so that you say you have gone into illegal accounts, all these things, and it was basically getting back the credentials of these users. Now we will see what are the ways by which, what are the different types of malware. It could be spyware, keyloggers, rootkits, mobile malware, and a combination of these. We will go and quickly see about spyware, keyloggers, rootkits, mobile malware in this talk. So what is a spyware? It is actually a passive malware. It does not show, it is sort of having lot of stealth. It just stays in your system, it does not interact with your user, So, from the user's perspective it is very stale, he does not even realize that there is a passive malware running. But what can this malware do? It can start spreading spurious packets on the network, choking the network, making an availability issue. It can pass on credentials to outside world. And actually it can frustrate the user by swallowing his complete internet bandwidth. Note that if you want to remove the spyware, lots of money are needed to remove spyware. And the spyware, like any other malware, can also come from the unauthorized downloads, like the mega upload case study that we saw in the previous module. The next type of malware is a keylogger. It is also known as keystroke logging. So, it can be both a hardware and a software. We saw an example of an hardware in the module 1, but it can also be a software. And what it does, it records all the keystrokes done by the user, because when you type in the key it goes to a driver, a keyboard driver, and then basically go to the memory. So, this keylogger will basically target that driver and it will get all the information. So, it can be a hardware or a software. We are now talking about software, and the software basically gets all the keystrokes of a given user, and these keystrokes may include your login and password. So, this can essentially lead to an identity theft. But note that these keyloggers, why at all you need keyloggers? If they are going to be identity theft, they are going to be against security, why at all you need a keylogger? The reason for having a keylogger is it will help determine source of errors on systems. It will also measure employee productivity on certain clerical tasks. So, a keystroke logger, if an employee does not hit one keystroke for say half an hour, then you will at least know that he has not been working with the system for half an hour. Maybe he is doing something else constructive, but at least you have a log of this. So, there are uses of keyloggers, and that is why keyloggers are still in place. But the negative side of keyloggers is that it can basically steal private information, including passwords. The other type of malware is called a rootkit. A rootkit is much inside, very close to the kernel, unlike the other malware that we have been talking of. It is into deeper levels of the kernel or very close to the kernel of the operating system. What will rootkit do? The rootkit is essentially to conceal the running process, file or system data, thereby helping an intruder to maintain access to a system while avoiding detection. So, the rootkit essentially promotes stealth, and these type of rootkits are known to exist for a variety of operating systems, and they are very difficult to detect. Now, things like high assurance boot, which we will be discussing in the next level 2 course in great detail, these type of high assurance boot, tamper, etc., can basically go and prevent a rootkit from entering a system. Nevertheless, these rootkits are very difficult to detect. With lot more mobile phone in place, lot more mobile phone viruses are being written, but however, if you look at a desktop, the percentage of the total number of vulnerabilities in a desktop running a conventional operating system to the total is very, to the total number of desktops running, that is very insignificant, this is very high. So, if you look at mobile malware, if you compare mobile malware to PC malware, this ratio, that is total number of systems running with a virus to the total number of systems in the network. So, that ratio is very, very small when we look at mobile malware, because there are so many mobile phones in the market, and whereas there are much lesser PCs in the system. Nevertheless, malware should take care of mobile malware because all the electronic commerce do happen through the mobile systems. So, today a combination of this, for example, I have a malware which is spreading, it is a sort of a bot we have seen earlier, it will just be spreading in the internet, but it will have a very lethal payload, it will have a very complex program, and if it gets installed, all your confidentiality, integrity and availability can go for a toss. Similarly, one can spam with already spoofed websites. A Trojan can be there which will keep installing bot software which can actually clog your network by creating lot of packets. You could have Trojans that are installing backdoors like the example I mentioned in module 1, where there was a very popular database, it was installed across the world, but if you actually give the username as politically and password as correct, then you get root access permission to any installation of this database. That is one very important backdoor. The Trojans can start creating such type of backdoors. Now, the next very important issue is the patch management. I buy a system and there are certain vulnerabilities. Now, the company asks you to update it. Very few actually do that update, right. So, what happens? The vulnerability still exists. So, if you look at in detail what could happen in the next few years is that 90% of the attacks would be on known vulnerabilities for which fixes exist. That is the way to solve the vulnerability, way to avoid or prevent or protect this asset from this vulnerability, those processes exist. But the thing is, those patches exist, but those patches are not actually applied on your system. So, over the next few years 90% of the attacks would be like this. It will be on known vulnerabilities which have a fix, but that fix has not happened because of certain patching failures. We will look at patching failures in more detail as we go through this module. Why does patch management does not happen? First thing is it does not scale well. The second thing is it is not cost effective. For example, there is a maintenance money that we need to pay to a software company on a consistent basis for them to release the patches. So, many of the organizations do not pay this annual maintenance contract. On an annual basis they do not do that, and that is the reason why many companies have systems in which these patches are not actually loaded, and because of that the security concerns continue to exist. So, a survey by the Yankee Group found that on an average $189 to $254 are spent per computer per patch. So, if you want to patch all the computers in large organization, it can cross $50 million per year, because these are licenses and floating licenses. And the other thing is, while applying the patch, your productivity goes very low. I have seen certain rural branches of a bank working. Morning when they switch on the system and they want to do an antivirus update from their data center, the entire system clogs, and sometimes the network also fails. So, essentially what happens is till the antivirus is updated, nothing happens and everybody waits for the antivirus to get updated, so that the bandwidth becomes a little more free for them to carry on the activity. So, because of application of patch, the productivity is lost. And another thing, of course, the cost is that a technician installation cost, which is quite heavy. We do not have trained people to come and do this, so the technicians are very costly people. It's very difficult to get a very good technician who has a full understanding of information security. Unfortunately, that is what we are in today. And so, to get a technician of that caliber and look at the installation is going to be a next challenge in patch management. Now, why patches are important? Now, look at this particular survey given in the URL that I have put there. Now, this was done in 2007, and there is a statistics of the different operating systems and how many vulnerabilities of different kinds that they had. For example, if you look at XP, there were 3 extremely critical vulnerability. For the Windows XP in 2007, there were 19 highly critical, 2 moderately critical, 3 less critical, and 34 are the total flaws. So, the average flaws per month was 2.83. For Vista it was 1.67, for XP plus Vista it was 3.67. Please note that in the second column, total highly critical, XP had 19 vulnerabilities, Vista had 12 vulnerabilities. XP plus Vista had only 23 because the vulnerabilities still were shared. So, some of those 12 vulnerabilities in Vista was common to some vulnerabilities in XP. So, this also states that when people start releasing new software, it is not guaranteed that all the bugs of the previous software are fixed, even all the known bugs of the previous software are fixed, because it may take much more time and much more understanding for industry to fix those vulnerabilities. So, here is an example which shows there is a statistics done in 2007, and it basically indicates that we need to put patches in. We have to be very rigorous in applying the patches so that the vulnerabilities get removed. If you have not done antivirus a patch from 2007, and say if you are a Mac OS X user, then you have at least 243 vulnerabilities in your PC, which is sort of very tricky. So, because of this vulnerability exploitation, operating systems are under consistent attack. Operating systems, conventional operating systems like even Windows and Mac OS X are under consistent threat or constant threat of being attacked. And how does the attack come in? The attack comes in through different desktop tools which are not connected with the operating system, people download. The attacks also come through alternative web browsers. The attack also comes through media applications and Microsoft Office applications, for example. So, since many of these are not updated against vulnerabilities, so from the date of their installation, so the hacker could actually exploit the vulnerabilities, known vulnerabilities today, but not their fixes are known, but they are not applied, but the hacker can basically use these to get access into the system and essentially create a vulnerability exploitation. There is also a very interesting trend called ransomware. What happens is the malware in your system will go and encrypt the victim's data. It will go and encrypt your data, you are the victim, and then it will also go and lock the screen or lock the screen. this will create an availability issue, you can't log in, you can't find anything. Then it actually starts demanding ransom for its restoration. So this is actually sometimes this is also called as cryptovirology, and in modern term it is called a ransomware. So in the next session we will start talking about distributed denial of service.